Hi, my name is Hira Ali, and I will be presenting you the Airspeed Indicator. This presentation will give you a better understanding of how the Airspeed Indicator operates, what to do if malfunctions occur with it, what the components are that make up the Airspeed Indicator, how they are used in aircrafts, what are the requirements for them, and what, where the Airspeed Indicator originates from. Starting off with a brief history, we have a man named Henry Pitot with a picture of him on the right-hand side. Henri Pitot was born May 3rd, 1695 in Aramon, France. He was a French hydraulic engineer and an inventor. He created the Pitot tube to measure the pressure of water flow in a river. I'll talk more about what the Pitot tube has to do with the airspeed indicator in a little bit, but nowadays the Pitot tube is used and defined as a way to measure the flow of velocity of airspeed for aircrafts and airplanes of any sort. In this slide, you will better understand what the airspeed indicator is used for and what certificate a pilot must have in order to fly and operate an aircraft. Airspeed indicators help the pilot read and understand how fast his or her aircraft is going in nautical miles. An aircraft must carry an airworthiness certificate with a picture with an example picture of it on the right hand side. Um, It says that every aircraft must have a working airspeed indicator, which must be checked every 24 months as a part of the FAR 91.411 inspection procedures. If you don't know what an airworthiness certificate is, it is one of the important documents that an inspector will ask for and you must have on the airplane for pre-flight inspections at all times. This is a diagram of a typical airspeed indicator. Um, you can see that it has markings and colored arcs and numbers on it. The different colors on the airspeed indicator represent different ranges of speed. The white arc represents the flaps operating range. The green arc represents normal operating range. The yellow arc represents caution or smooth air only range. And that red line indicates the maximum aircraft speed. It is different for every aircraft what the maximum speed it can travel and where that red line is located. Each line has a starting and end point, and each starting and end point have a particular V speed. Starting from the top right, we have VSO. VSO is the beginning of the white arc, which is the stall speed and landing configuration. At the end of the white arc is VFE, which is the maximum flaps extended speed. That's when you can operate the flaps. You can't operate them past that white arc. The green arc starts from VS1. Sometimes it's called VS, but in this picture diagram it shows VS1. And that is the stall speed in a clean configuration. At the end of the green arc, and it starts off with a yellow arc as well, in between there is the maximum structural cruising speed. If you happen to fly into the yellow arc, you should be in smooth air only and make sure you drive in a straight and level position. You can't make any fancy maneuvers, turns, swirls, otherwise it will cost you. And then the last speed we have is that red line, which is called VNE. Another name for VNE is the never exceed speed. If someone happens to exceed the red line, the aircraft is pretty much in a risk for structural damage. Um, it's different for every aircraft where that red line is located. Every airplane has an airspeed in knots. That's what the airspeed is measured in. Um, the older aircrafts, they show in miles per hour, but that was just for advertising. Um, there are 6,080.27 feet in a nautical mile, whereas a statute mile has 7,280 feet. 1 knot is equal to 1.15 statute miles. So if you're going 40 knots um, in the white arc, you are going a little more than 40 miles an hour. Now we are moving on to the components and how the airspeed indicator is made. There are two main parts for the airspeed indicator. First is the pitot tube, which I talked about earlier. It's commonly located on the wing. If it's not on the wing, it's towards the front of it, and it's facing the headed direction of the aircraft. So it can take in air as the plane flies. The second part is the static airline, which comes in through the static port. A pitot is used to measure the airflow of aircrafts, water speed for a boat, and to measure liquid, air, or gas flow in velocity. The pitot tube measures um, two pressures, static and total impact pressure, or ram pressure. It's in a form of a slender tube with two holes in it. The first hole measures ram pressure, which is the pressure from the plane moving, and the other hole, which is the static pressure, which is the air pressure that surrounds the aircraft at any given moment. By measuring the differences between these pressures, you get the dynamic pressure, which helps calculate the airspeed. When they enter, when the air enters through those lines and tubes, it goes into the diaphragm, which moves a little pin, which turns two other pins, which controls the airspeed indicator's pin, which turns around as the airs move within the whole round dial. Now we're moving on to possible malfunctions and their solutions. During your pre-flight inspection, you should check if the pitot tube is in place and free of cracks or loose, like if it's not loose or anything. Otherwise, it could be harmful when flying. The pitot tube can be blocked by icing, um, as it shows on the picture on the left. There is a pitot tube heater switch in the cockpit to defrost the pitot. Um, it can also be blocked by bugs, as it shows on the picture on the right, or trapped water. When the pitot is blocked, the airspeed will not be indicated correctly, and if the airs continue to be there, it can the airspeed indicator can drop to zero, and it will just continue to get worse and worse. A solution to these problems is to clean the pitot tube during the pre-flight inspection and make sure it is unblocked from any sort of hazards. These are my sources that I got all my information from. Thank you for listening to my presentation. If you have any questions, leave a comment below.